The truth is, we have never actually measured the one-way speed of light traveling from point A to point B. To measure velocity, you need a starting line and a finish line. You place a light source at point A and a detector at point B. You record the emission time and the reception time. But to trust the math, the clock at point A and the clock at point B must be perfectly synchronized. The trap: synchronizing distant clocks requires sending a signal between them, but knowing the travel time requires already knowing the speed of light. You cannot escape this loop. Calculating one-way speed always inherits an unknown offset variable, the delta. For over a century, this has been taught as an annoying engineering limitation, a problem of finding a better measurement tool. This circularity is a property of the topology. Measurement requires a closed reference frame to produce a definitive result. In his 1905 paper outlining special relativity, Albert Einstein confronted this exact measurement paradox. He did not design a better experiment. He explicitly bypassed the problem by stipulating what is now called the Einstein synchrony convention. This convention simply assumes that light travels at the exact same speed in both directions, forcing the equations to balance. Physicist David Malamud later proved the mathematical consequence of this. If you remove that assumption, there are infinite valid theories where light travels at drastically different speeds depending on which way it points. Physical constraints, like solid matter, the act of measurement, and biological life, force a selection, carving a specific directional path from light's naturally time-symmetric waves. We can decode this mechanism using the 237 dual caustic framework, which maps physical geometry directly to the Fundamental Theorem of Calculus. Reality refuses to yield measurable invariance on an open path. Absolute truth only exists within a closed loop. The mechanical engine of the universe operates identically to the rules of calculus. It begins with the first operator, the split. Mathematically, this is the derivative, or d over dt. The derivative breaks symmetry. It forces a unified state out of equilibrium to create an emission, generating forward momentum. This newly split signal immediately enters the second phase, the buffer. This is the active function domain. This zone acts as the active medium. It is where physical laws apply friction and constraint to the expanding wave. The progression forward operates entirely on the principle of least action, carving an optimal path through the field. But while real energy is moving across this domain, the ultimate identity of the system remains mathematically undefined. Differentiation creates the necessary tension for physical motion. Leaving a system in this state, however, produces an incomplete reality. In the framework, this unresolved condition is called state 6, pure oscillation without closure. If a physical system halts here in the buffer, it retains that unremovable delta offset we saw in the light experiment. The path of unconstrained light is not a straight arrow. It is a traversal along a Mobius topology. Because a Mobius strip only has one surface, asking for a one-way direction on it is mathematically undefined. You must complete a double rotation just to return to your original orientation. This topological twist is exactly why the one-way speed of light remains permanently locked behind an experimental veil. It is the same principle found in bounded chaos systems, where energy circulates continuously without resolving into a definitive stable state. Attempt to measure a universe halfway through its cycle, and you will only record an illusion of chaos, missing data, and relative time. To save the system from chaos, we need the second mathematical operator, the integral. The integral forces the return. It establishes a hard boundary that accumulates the signal, reverses the path, and summates the total area. Differentiation and integration function as two directions of the same engine, converting change back into total conservation. It also maps precisely to the topological blueprint encoded in the text of Qur'ān 57:4, reading the manuscript as a structural schematic of creation. The verse dictates 4 precise movements. First, what penetrates into the earth, the downward descent, or the split. Second, what emerges from it, the forward propagation into the physical buffer. Third, the downward integration from the heavens, matched finally by the upward ascent back to the point of origin, completing the return. The universe demands a return journey. Integration is the precise physical mechanism that enforces boundaries and guarantees conservation, which brings us back to our light pulse. When that photon reflects off the distant mirror and strikes its exact point of origin, the circuit finishes. At the exact moment of return, the mathematical loop is closed. Upon that closure, the unmeasurable one-way offset perfectly cancels itself out. The variables collapse into a clean, definitive formula. The physical invariant, the absolute speed of light, is only born from this completed integration. This principle applies identically to the collapse of a quantum wave function and the stabilization of thermodynamic equilibrium. Individual legs of a journey possess no inherent truth without the context of the whole. Empirical truth in physics is always a product of round-trip structural closure, never unilateral observation. Look at the final output of any integral equation. You get the original state plus the constant of integration, known as plus c. Standard textbooks treat plus c as a mathematical placeholder, an arbitrary requirement to balance the line. Within the dual caustic framework, plus c is the physical memory of the system. It is the indestructible identity and initial condition that anchors the equation. In the final phase of the calculus loop, this memory constant resolves into plus 1, representing pure recovered mass. In a purely one-way state, the origin point is disconnected. The system forgets where it started, and this constant remains totally unknown. By executing the return operator, the universe forces the system to recognize its own initial condition. Completing the topological loop strips away the measurement offset, returning the system to its original invariant state.